Good morning or afternoon. I don't know. Depends on what time you are watching this. So today we are continuing. So last lesson we did ratios and proportions, and we need that for today's lesson. So today we are talking about similar polygons. So what does it mean when we talk about similar shapes? So two figures that have the same shape but are not necessarily the same size are similar. Okay, so our similar symbol is like the top of the congruent symbol, just a squiggle like that. So similar figures have the same shape but possibly different sizes. And when we have this, all of our corresponding angles are congruent and our corresponding sides are proportional, okay? So angles are congruent and sides are proportional. And that proportion of the lengths of the corresponding sides is called the similarity ratio. Okay, so the similarity ratio is the ratio of proportional sides. Okay, let's erase that. Not proportional sides, the ratio of corresponding sides, excuse me. Okay, so what does that mean? Let's look at some examples. So if I have quadrilateral ABCD is similar to quadrilateral EFGH, then let's complete each statement. So remember, all of my corresponding angles are congruent. And so this tells me angle A is congruent to angle E. So angle A and angle E are congruent. Angle B and angle F are congruent. So angle B and angle F are congruent. Angle C and angle G would be congruent. And then lastly, angle H and angle D would be congruent. So to use that to answer, the measure of angle E is going to be congruent to angle A, so that's 53 degrees. And when I talk about corresponding sides being proportional, remember the order of the letters helps you. So AB is going to be proportional to EF, and BC is proportional to FG. And let's see what else we got. We got HG and DC, and then our last side here, AD, would be proportional to EF. So if I have AB, which I highlighted in blue, over EF, which is also in blue, then I have AD, which I underlined in a pink. So then the other pink would need to be EH. So my answer for this last one would be EH. So how I always think about setting up these proportions is think about like having a table, and you can label your table two ways, okay? So on the top, if I look at how this one worked, on the top, these were both from my big quadrilateral, okay? And on the bottom, it was from the small quadrilateral. And then my columns on my table, okay, so this is big and big quadrilateral here, small quadrilateral, small quadrilateral. And then when I went within each fraction was corresponding sides. So AB and EF were corresponding sides. So it was blue side. And then we had the pink side, okay? So these were corresponding sides. Side blue, side pink, okay? So big blue side, small blue side. Then I had big pink side and small pink side, okay? So if you organize it that way, even if you flip your columns and rows, your proportions will still be correct because of those properties of proportions we talked about last lesson. Okay, let's continue on. Our next set of examples say determine whether the triangles are similar. Sorry for moving this around all the time. Determine whether the triangles are similar. If they are, write a similarity statement and give the similarity ratio. Okay, so for this one, let's first determine our corresponding sides. So they already showed us our corresponding angles. So A would be corresponding to F, B would be corresponding to E, and D would be corresponding to C because those are the congruent angles. So my corresponding side, AB, from one arc to two arcs, would have to correspond to EF. Then BC from 2 to 3 would correspond from D to E because that's also 2 to 3. And then my last side would go from 1 to 3 arc. 1 to 3 arcs would be here. Okay, so these do not have the same orientation like my previous example. So sometimes you have to look and make sure you're talking about your correct corresponding angles. All right, so are they proportional, right? That's our question, proportional. So just like we did in the previous example, I had a fraction that talked about the big one to the small one, right? So let's see here. So if I talk about, let's do the yellow sides. So yellow side, and let's list our sides. Yellow side, blue side, and lastly we had green side. Okay, and then within those fractions, I am always going to have the top of my fraction come from the same shape. So the top, let's do the small triangle. And on the bottom, let's do the big triangle. Okay, so yellow, blue, and green. Okay, so on my yellow triangle, I have 15. On the yellow side is 15, and on the big triangle, the yellow side is 20. On the small triangle, the blue side is 12, and the big triangle, the blue side is 16. On the small triangle, the green side is 18, and on the big triangle, the green side is 24. So now my goal is to see, are these equal? That's the question. And if they're equal, then yes, they are similar. So let's reduce these fractions. So my first set of fractions reduces to 3/4. My second set also reduces to 3/4. And my third is 3/4. So yes, we would say these are similar because they all are proportional. So yes, they are similar. Okay, so let's make sure if they are similar, write a similarity statement. Okay, so my similarity statement is very similar to congruent statements. So if I called the first triangle ABC, I would say that is similar to triangle. Now we have to make sure we go in the right order. So ABC, so FED would be the correct order for the second triangle, making sure I'm lining up my corresponding angles. And then my similarity ratio would be 3/4, okay? Or you could say 4/3, depending on if you put the big triangle over the small triangle. Either way would be appropriate, okay? So your similarity ratios can be flipped depending on which triangle you're comparing to which one. All right, our last example says sketch triangle. Oh, no, sorry, not our last example. Sketch triangle XYZ and triangle MNP with angle N congruent to M, Y congruent to N, angle Z congruent to angle P. Also, we want XY equal to 12, YZ equal to 14, and XZ equal to 16, and so on and so forth. Can you conclude the two triangles are similar? All right, so let's sketch these out. So it looks like XYZ is a little bit smaller than triangle MNP. Okay, so XYZ. So XY is 12, YZ is 14, and ZX is 16. Okay, and then I have a little bit bigger triangle here. And this is MNP. And MN is 18, NP is 21, and MP is 24. Okay, So can you conclude that the triangles are similar? All right, so angle X is congruent to angle M. Oops, I did not draw them the same. Angle Y congruent to angle N. And angle Z congruent to angle P. Okay, so let's go through and highlight our corresponding sides. Okay, so X and Y are going to be corresponding to M and N. Okay, because it goes from one arc to two arcs. X to Z, 1 to 3, is going to correspond to M to P. And then lastly, I'm going to have Y to Z is from one arc to 3 arcs, which would be this one. You can also think about the shortest sides have to be corresponding, the longest sides have to be corresponding, and the middle length sides have to be corresponding. So you can also think about it that way too, instead of between which congruent angles. Okay, so when I set this up, let's put our small triangle on the top again. I like to be consistent. And the big triangle is going to be on the bottom. Okay, and then my sides, remember we're trying to see, are these equal? Okay, I don't know they're equal yet, so I'm not going to write that they're equal. So then let's figure out our sides. So we got the yellow sides, we got the blue sides, and we got the green sides. So when I fill out the yellow sides, so small triangle, yellow side is 12. Big triangle, yellow side is 18. Small triangle, blue side is 16. Big triangle, blue side is 24. Small triangle, green side is 14. And big triangle, green side is 21. So when I go through and reduce these, 12, 18 would be 2/3. Divide both by 6. 16 over 24, divide both by 4. I get 4/6. Oops. Let's divide both by 8. So then I get 2/3 as well. And if I divide 14 and 21 by 7, I also get 2/3. So here we go. So my answer is yes, they are similar. And it asked me to explain. And I would explain because corresponding sides are proportional. Okay, and that similarity ratio is 2/3. So if I did this problem and one of them was not 2/3, they would then not be similar. Okay, last example, right? Yeah, this is a last example. I'm not lying this time. Okay, this one says quadrilateral LMNO is similar to quadrilateral QRST. Find the value of X. All right, go ahead, pause the video, try this one on your own, set up a proportion, and solve, and then come back. All right, so when I want to set a proportion to this, it tells me how the sides are proportional, okay? So NO is going to be proportional to ST, great. And then I'm going to pick, instead of using 3.2, I'm going to use that side 5 because it looks to me like it's proportional to 6. It looks like it's corresponding side to 6. So let's check my letters, LM and QR. Yep. Looks great. Okay, so once again, let's do my small figure. Oh my gosh, why? Why do I keep writing wrong? There we go. Small over big. Okay, and then I'm going to set up one fraction with the yellow sides and one fraction with the green sides. And so my yellow side on my small is 2. The yellow side on the big is X. The small green side is 5, and big green side is 6. So then I'm going to cross multiply to solve my proportion. So I'm going to have 5 times X equals 2 times 6. So 5X equals 2 times 6, or 5X equals 12. Divide both sides by 5. I get X equals 12/5. Or if you like decimals, which I know a lot of you do. And for this, you can give me an answer in decimal, which is 2.4. And the reason why I accept decimal on this problem is because in the problem, they had a decimal, okay? So typically you're going to use fractions unless the original problem had a decimal or it's a story problem where units are involved, okay? So go ahead, try the homework, and I will see you in class if you have questions.